I had an interesting conversation this week with a member of the audience. It was about telecommunications enclosures versus a telecommunications room. And that made me realize that not everybody might know the difference between those two. So you guys might need to hear the requirements for a telecom enclosure. That's the subject of today's show.
Don't hang up that phone. We've found what you're looking for. Welcome to the Let's Talk Cabling Podcast with Chuck Bowser, RCDD. Well, seeing how we're pulling Category 6A, the most powerful twisted pair in the world, you got to ask yourself this one question. Did I pull 295 or 300 feet? Well, do you feel lucky? Do you, punk? In this podcast, you'll learn the differences between a 66 and 110 punch tool, the proper way to install a support cable, along with testing and certifying the cable. What exactly does RCDD stand for? Registered Communications Distribution Designer. Just the expert you need to ensure your cable plant performs exactly as designed. The elite professional, knowledgeable, and experienced in leading-edge ICT design principles. So join us as we talk about the ever-changing world of telecommunications. From ISP to OSP, from copper to fiber, design to installation. Now, send the new guy to the truck for a bucket of dial tone and the cable stretchers, while you listen to an informative program on telecommunications.
Welcome to the show where we tackle the tough questions that are submitted by installers, project managers, estimators, IT personnel, and customers. On this show, we connect at the human level so we can connect the world. If you're watching this on YouTube, would you mind hitting the subscribe button and the bell button to be notified when new content is being produced? We're also just a few subscribers away from hitting 100. So won't you please consider subscribing to the channel? Help us break that goal. If you're listening to this podcast on iTunes, Stitcher, or some other platform, would you mind consider leaving us a rating? Hopefully a 5-star rating. If it's not, email me, chuck@letstalkcabling.com, so we can figure out what I need to do to get that 5-star rating. Both of those steps help us take on the algorithm so more people can hear this message, so we can encourage, educate, and enrich more people's lives in the ICT industry. Also, don't forget our After Hours live broadcast series, broadcast Thursday night, 6 p.m. Eastern Standard Time, where you get to submit your questions that's just been bugging you for who knows how long to be answered live by your favorite RCDD. That would be me. And this is why you can watch us on LinkedIn and YouTube live. But if you don't get to watch it live because you're working that night or you've got kid duty, they are recorded for later consumption. So make sure you send your questions to questions@letstalkcabling.com because submitted questions get priority over the live ones. Also, make sure you check out our webpage so you can find out all of our recorded podcasts, our recorded vlogs, and articles. You can even sign up for our newsletter, where once a week you'll get notified when new content is being produced. And there's also ways for you to support this platform, either through Patreon or a one-time donation through PayPal. So today we're talking about telecommunications enclosures, or TEs for short. There will be times where you're going to need to have an additional or a supplemental connection point somewhere on the floor, and it's outside of the range of the telecom room. And the customer is not going to want to pay the additional expenses to build out that telecom room because it can be expensive when you factor in all of the trades that's going to need it for that. So just for clarification, the 569 standard calls the telecommunications enclosure a distributor enclosure. The TDMM and everybody else calls it a telecom enclosure. For those who may not know, the TDMM is the Telecommunications Distributions Methods Manual. We are currently in the 14th edition. Before we go too much further down this road, I want to talk base real quickly on should and shall. Should and shall are two very specific words. Shall means you have to do it. Should means it's a recommendation. So if I say should and shall in today's podcast, it's verbatim from the standards. Now, some examples of why you might need an additional connection point somewhere in the building. For example, your run length might exceed the allowable length for a permanent link, or 295 feet, or 90 meters. One good example was a graphic t-shirt place that I cabled up once when I was in Prince George's County, Maryland. Now, the name of the company is escaping me, but they were over by the old Cap Center. And there's a store, there's an old warehouse, and the front third of it was a store where you could go in and purchase t-shirts. They also offered them online for people to buy as well. Now, the back 2/3 of the building was where they produced the t-shirts and shipped them online. Now, the majority of the work area outlets, the drops, were actually in the front of the building, in the store, for the cash registers and the administrative staff. But there was one drop. There was one work area outlet that was all the way in the back of the warehouse, where the warehouse manager sat. He had a printer and a terminal, so he can log on, check their emails, and print labels. Well, that location was well beyond the 90 meters that were allowed to be there per the standards. And the customer did not want to build another telecom room in the warehouse just for that one drop. The telecom enclosure came and saved the day. Another example of a space that's going to be using a telecom enclosure is a building that may not be an office building. For example, Walmart's. A Walmart's a huge building, and they generally going to have somewhere between 500,000 square feet to over 1 million square feet. And the areas that actually have work area outlets are confined to just a few locations. For example, the cash registers or the point of sale system, the office area, or maybe the back where the automotive or the camera photo development place is. They just don't need a telecom room every 10,000 square feet as the standards mandates. There's just not enough drops to sustain one every 10,000 square feet. So typically, they're going to put a telecom enclosure near those clusters. And some of them, those telecom enclosures, will feed back to a telecom room. Now let's start off with the main difference between a telecom room and a telecom enclosure. So the 14th edition of the TDMMs basically says a telecom enclosure is simply a case or housing for telecommunications equipment, cable, terminations, and cross-connect cabling. The key word in that sentence is an case or enclosure or housing. Perfect examples are enclosed racks, wall or ceiling mounted enclosures, which are probably going to be the most typical. As with the big brother, the TR, it is also going to have needs for access, pathways, lighting, power, and bonding and grounding. Those are all considerations that you need to think about when you're designing, installing, or certifying a telecom enclosure. This room should be dedicated solely to the functions of the telecommunications or the ICT cable plant or related support functions. Now, while generally telecom enclosures are usually filled with passive equipment, you may encounter the need to place an active equipment inside of that enclosure for devices such as, for example, a wireless access point. Now, I want to be inclusive here because maybe not everybody knows what active and passive means. I don't want to assume that everybody just knows the difference. So active means that piece of equipment needs to be plugged into an electrical receptacle in order for it to work. Okay? If it's no electrical receptacle, it will not work. Passive means it does not require an electrical receptacle. Think of a patch panel or patch cords or a 110 block. Those are good examples of passive equipment because they don't need an electrical receptacle in order to be plugged in. When it comes to determining the correct size of the telecom enclosure, you're going to need to know what equipment is going to be installed inside of it. What passive equipment, patch panels, 110 blocks, wire management rings, what active pieces of equipment are going to be installed inside of it. And also, you need to think about what's going to be needed for future growth. Good general rule is assume 50%. By their very nature, over the lifespan of the structured cable plant, the telecom enclosure will have stuff added to it. And the final, probably most overlooked consideration for sizing this right-sized telecom enclosure for the system that you're putting in is make sure that you are going to be compliant with the minimum bend radius of the cable type that you are installing. If you exceed the cable bend radius, you will affect the performance. The customer will not get the bandwidth that they wanted in order for the network to work correctly. Now, while you're going to want to install the telecom termination equipment inside of this telecom enclosure, for example, like patch panels, 110 blocks, ensure that the rails and mounting hardware are compliant with the EIA ECA 310E standard. That's going to make sure that the holes are the right distance apart and the threads are correctly. If you're mounting termination blocks, then you're either going to make sure that the rails meet that standard, or you might have to put plywood inside of that telecom enclosure, depending on which type of 110 block that you pick, because they have rack-mounted and wall-mounted 110 blocks. You need to know that in advance when you're trying to pick out the right telecom enclosure. Pro tip number 1, you're going to want adequate light inside of this enclosure. So the standard basically tells us that we have to have a minimum of 500 lux inside of it to minimize the shadows inside of this enclosure. The TDMM calls for 538, or basically 50-foot candles. 1 foot candle is defined as enough light to saturate 1 square foot with 1 lumens of light. You also want to make sure that there's enough light so you can adequately tell the difference between the different colors when you're terminating and read the labels. Do not overlook the door either. Give it careful consideration, such as making sure that either the door is going to open up a minimum of 90 degrees or open up enough so you can provide unobstructed access where the technician can get inside of the enclosure. The door should remain open until the technician decides they are done and they need to close it. Because if it doesn't, then it's going to swing back, it's going to hit them, cause an injury. You want to make sure that they can work on the equipment, the cable, and the termination blocks safely. The key is safely. You and the end user are also going to want to control the temperature and the humidity inside of the telecom enclosure, because the higher the temperature, the worse the cable performs. The higher the temperature, the worse the equipment's going to perform. You're going to make sure that the temperature and the humidity meet the requirements by the ASHRAE Class B guidelines. For those who may not know, the ASHRAE is the American Society for Heating, Refrigerating, and Air Conditioning Engineers. Think of them as Bixby, but for the HVAC world. Now, the Class B rating basically means that telecom enclosure is designed for a temperature range of somewhere between 41 and 95 degrees Fahrenheit, or between 5 and 35 degrees Celsius for my people over in Europe. It also has to have a dry bulb range between 2 and 3, and a humidity range between 8% RH to 82 degrees, and a DP and 80% RH. If you want to see more, there's a document in our description link below, which will give you access to that document so you can read it for yourself. Also, keep in mind that when you put in active equipment inside of an enclosure, that you need to make sure that you're going to know that the equipment's going to generate enough heat, and that's going to cause that equipment to fail quicker. It's going to cause that cable to perform worse. The electronics need to be kept cool, and they need to be kept cool. You need to make sure there's enough air exchange to keep that piece of equipment cool. In the electronics world, there's this thing called the half-life rule. For every 10 degrees above ambient temperature that a piece of equipment is exposed to, you reduce the lifespan of that piece of equipment by 50%. There's also a great link to another article in the description below in the YouTube channel description. When it comes to power inside the telecom enclosure, the standard tells us that we shall install a minimum of one dedicated 120 volt AC nominal non-switched duplex receptacle. It has to be rated for 20 amps and has to be connected to a 20 amp branch circuit. If you're not a journeyman electrician, please consider hiring a journeyman electrician to do that work for you. The key in that sentence is non-switched. Okay? You don't want somebody accidentally flipping off a light switch somewhere that turns off the power to the equipment inside of that enclosure, because then a whole bunch of people on the network are going to lose their connectivity. Also consider a duplex convenience receptacle that should be provided inside that telecom enclosure. It should be on a separate branch circuit from that other receptacle. This is going to come in handy for your network engineer or your ICT technician when they want to plug in their network sniffer or their ICT cable tester or certifier to troubleshoot things. You don't want them disconnecting your active equipment to plug in their testers. If there is standby power available via a generator or some other type of backup system, ensure that the equipment inside that telecom enclosure also has availability to that standby power. If you have equipment components inside of the enclosure, for example, like a shielded cable solution, shielded patch panels, shielded patch cords, they need to be bonded to a ground, and that bonding needs to be done per the 607 bonding and grounding standard. If the enclosure is made out of metal, then that also has to be bonded to a ground to be compliant with your authority having jurisdiction if they require one. When in doubt, bond it to the ground. It's better to be safe than not safe, because we're talking about life safety when you're talking about bonding and grounding. There are a few other things in the 14th edition of the TDMM that are not found in the standards. Let's cover a few of those. The first is the TDMM states that the telecom enclosure shall be accessible, but the access should be controlled against unauthorized access. So carefully consider where you place your telecom enclosure. You're going to want to be able to get back into that telecom enclosure at a later date. Trust me. Don't put it somewhere where you're not going to be able to get back into this telecom enclosure, because you need to get into it to do the servicing. As for controlling against unauthorized access, you actually have a couple options. The first one is to purchase the lock kit for that enclosure. That lock kit that comes with a kit, and then you give the key to the facility or the property manager for them to hold on to anytime that you need to come back and do work to that system. You can also mount the enclosure up high where nobody has access to it. Now, many stores will mount them up so high that's going to require a lift in order to get access to the telecom enclosure. Pro tip number 2, make sure that you attain training and wear and don appropriate PPE before operating any lift, hoist, or any other device. According to OSHA, over a 1-year period, 10 preventable fatalities and over 20 preventable injuries were from the use of a scissor lift. And those injuries came from inadequate protection, inadequate training, or inadequate fall protection, or positioning or stabilization of the equipment. If you're renting a piece of equipment like a scissor lift, the rental firm will be able to provide you training on that piece of equipment. Require it. A certified safety professional should be able to teach you how to determine what's the appropriate fall arresting gear that you're going to need while operating on that scissor lift. Second thing, the TDMM recommends that installing the telecom enclosure, or against installing inside the telecom enclosure inside of modular furniture, unless that first piece of furniture is bolted to the building. They stipulate that same requirement for MUTOAs, multi-user telecommunications outlet assemblies. The third thing is the TDMM stipulates that the cable pathway shall not pass through the telecom enclosure. If the enclosure is metal, then the AHJ is going to require you to install a bushing, a grommet to protect that cable so it doesn't short something out. If the enclosure is non-metallic, the edges around the hole may be rough and may damage the cable as well. Protect your cables, even though they may not be a hazard from electrical shock because the cabinet's not made out of metal. Still protect those cables. The fourth additional requirement per the TDMM is to set a limit to serving a maximum of 3,600 square feet. There also used to be a requirement for a maximum of 288 connections, but that was removed. The telecom enclosure is a supplement to the telecom room, not a replacement to it. Pro tip number 4, be aware that some manufacturers, not all, but some, are going to require that the telecom enclosure is a minimum of 50 cable feet away from the telecom enclosure or the other connection point, such as a horizontal connection point. Make sure that you ask first so you can plan for this by leaving additional cable coiled up between the telecom enclosure and the horizontal cross connect. And that was one of the items that I discussed with the listener who reached out to me. They had indicated that the area that it served was potentially 4,000 square feet, which definitely put it outside of that range of the telecom enclosure. So there's your requirements for a telecom enclosure. I hope I made it a little bit more clear so now you can understand the difference between a telecom enclosure and a telecom room. So until next time, be safe.